Okay, hello. This is the Black Workshop here. I'm doing a study guide, audio study guide for people to study this recording an audio of certain notes to just repeat and study and memorize for the EPA's refrigerant with certification test. Hold up. I'm in a moving vehicle right now, so just hold up on me real quick. First, I'm gonna start off with the dates, the important dates. This is one of the things that confused me the most, is memorizing all these damn dates. Okay, so some of the important dates obviously was the Montreal Protocol, which was 1987. So 1987 was the Montreal Protocol. 1987, the Montreal Protocol. Okay, that's what the current tax rate schedule on CFC refrigerants. And 1990 was the Clean Air Act Amendment. That's 1990. It's the Clean Air Act Amendment. 1990, the Clean Air Act Amendment. Refrigerant products cut and banned. So they start cutting and banning certain refrigerants. Okay, now July 1992. This is one of the ones they try to throw you off with. July 1992. So July of 92 is when they unlawful to vent CFCs and HCFCs into the atmosphere. So that's when they made it. You can't vent those CFCs and HCFCs into the atmosphere like R22 and R12 and stuff like that. You got to use those special clips to clip onto the system when you're doing recovery. That's 1992 of July. Unlawful to vent CFCs and HCFCs into the atmosphere. Okay, now the November 15th of 1995 is when it became unlawful to vent alternative refrigerants, which is HFCs, into the atmosphere, like R134A and some other HFCs. But we'll get to those. But just remember that 1995. That's the November 15th of 1995. So I guess you can think of the two fives, 15 and 95. November 15, 1995. Unlawful to vent HFCs into the atmosphere. Okay, so in 1996, they tried to phase out the CFCs. So that's where they tried to get rid of the R12s. That's 1996. So 1996, they tried to phase out CFCs. And they also tried to freeze out HCFCs. So they're trying to move away from the CFCs and HCFCs in 1996. They try to phase them all out. Okay, 1997, the Kyoto Protocol intended to reduce worldwide global warming gases. Global warming has become a major environmental issue. So that's 1997, the Kyoto Protocol to reduce global warming gases. Okay, 1998, the EPA proposed more strict regulations on recovery recycling standards, equipment leaks, and alternative refrigerants. So that's 1998. The EPA proposed more strict regulations on recovery/recycling standards, equipment leak rates, and alternative refrigerants. Let's see. So by 2020, no production and no importing of HCFC 22 or R22 as we call it they plan that by 2020. So keep that in mind. 2020, no production or importation of R22 pretty much, which is a HCFC. And then by 2030, they want no production and no importing of any HCFC. Not just R22, but any HCFC by 2030. So 2020 is they're gonna totally get rid of R22. You can't import it, nothing. No production, no import, nothing of R22 in 2020. But in 2030, they want to get rid of all HCFCs. Okay. Now let's get to the other little knickknacks here. Okay, let's see here. We got dates. Let's see here. Let's go to the let's go here to these refrigerants. Okay. Now another rule of study here is the rule of 90. If you take the refrigerants, the number that the refrigerant has, and you, what was it? How did it work? You gotta add, I believe, what? You add 90. Yes, add 90 to that number, and you'll have probably a 3-digit column of numbers. The first number is going to be, the first column is chlorine, the second column is hydrogen, and the third column is fluorine. So you can use that formula to identify the number of chlorine. Excuse me, the first column is carbon, the second column is hydrogen, and the third column is fluorine. You can use that formula to calculate how much chlorine is in each refrigerant atom or molecule. Excuse me, molecule. But let's talk about the CFCs and the HCFCs and the HFCs. CFC, which means carbon, fluorine, and it's chlorofluorocarbon. Excuse me, chlorofluorocarbon is the CFCs. Where the HCFCs is hydrochlorofluorocarbon. So as I was told, the first C in those in the abbreviation, the first C is always the chlorine. So chlorofluorocarbon, like CFC. And HCFCs is hydrochlorofluorocarbon. And the one that has the least ozone depletion level is the HFCs. But let's go to this here. Let's see. Okay, CFCs. It says if all the hydrogen atoms have been replaced in the base molecule by chlorine and fluorine, the refrigerant is said to be fully halogenic and is referred to as a CFC. Refrigerants such as R11, R12, R113, R114, R115, 502 are phased out because of manufacturing bans, which started December 31st, 1995. Another date there. So the December 31st of 1995 is when they all got phased out for manufacturing bans, specifically the R11, R12, R11.3, 11.4, 11.5, and 502. 502, I believe, is a blend as well. Let's see. Okay, it says also both R11.3 and R11.4 of the ethane series halogen are CFCs. CFCs are very harmful to the atmosphere and have the highest ozone depletion potential because they carry the most chlorine. but the CFCs have not been produced since 1995 because of their detrimental effects on the atmosphere. It is chlorine in the CFC molecule that is very stable and will not break down for long periods of time. CFCs are not water soluble and do not wash out the atmosphere with the rain. That's a key point to remember. They do not wash out of the atmosphere with the rain. Chlorine molecules will reach the stratosphere and react with the ozone, thus depleting the ozone layer. It is the ozone layer that protects the earth from the sun's harmful ultraviolet radiation. So as I was taught to understand this, the ozone is made up of O3.
I gotta call you back.
O3. O2 is what we breathe in. Think about that. O2 is what we breathe in. So this is how it works. When the chlorine goes into the atmosphere, it bonds itself to other oxygen atoms, freeing up oxygen atoms and converting like oxygen 3, which is 3 oxygen atoms, into oxygen 2. That's what we breathe in the lower atmosphere levels. But in the upper atmosphere air levels, we have O3, which protects us from ultraviolet radiation from the sun. So by changing that into the oxygen atom molecules that we breathe, it's not causing the same level of protection that we normally get from that O3. And then same effect on the O2. We breathe in the O2, not the pure 100% oxygen of single atom oxygen molecules. So this could have long-term effects because they could stay in the atmosphere for hundreds of thousands of years. Okay, now let's continue going here. HCFCs, the base molecule of methane or ethane, can be either fully or partially halogenic. With CFCs, the molecules are fully because no hydrogen atoms remain. This gave CFCs a very stable configuration, thus a longer life. CFCs will eventually reach the stratosphere and deplete the ozone. Okay, let's see. Okay, so now it says because some hydrogen atoms still exist, the entire molecule is referred to as hydrofluorocarbon or HCFC. Some HCFCs used today are CFC 22, which is R22, R123, and R124. Those are HCFCs. So the R22, R123, and R124. They have shorter atmospheric lives. They have less ozone depletion potential, or ODP, as they use for abbreviation, ozone depletion potential. And they call them HCFCs. And we know HCFC is R22, R124, and R123. They are less detrimental to the atmosphere and most have much less ozone depletion and global warming potential than CFCs. The HCFCs molecules contain chlorine, fluorine, hydrogen atoms that bonded to a carbon atom. Because HFCs do contain chlorine, they still damage the ozone layer if they reach it. However, because of the hydrogen bonds, these molecules are much less stable and have shorter lives. Therefore, not many HCFCs reach the stratosphere. Okay, let's go to the next one. Now, the HFCs, or the hydrofluorocarbons. Now, these alter a base molecule is a halogenic by the fluorine atom only. There are no chlorine atoms anywhere in the molecule. Okay. Now, let's see. Look, there's no chlorine atom in the molecule, only fluorine and carbon atom. because HFCs contain no chlorine, they have an ozone depletion potential of 0. That's important to remember. HFCs contain no chlorine. So hydrofluorocarbon, or HFC, not to be confused with the HCFC, but the HFCs contain no chlorine, and they have an ozone depletion potential of 0. However, they do have a small global warming potential. Okay, several HFCs refrigerants which has increased in popularity are R32, R134A, R143A, R152A, and R125. So that's the HFCs. It's the R32. Remember, R32 is HFC 32, R134A, R143A, R143A, R152A, and R125. Now, HFC 134A, or R134A, someone let's call it, is an alternative refrigerant choice to replace C12 and HCFC 22. That doesn't mean that it's a drop-in. Don't confuse that with a drop-in. That means you can't just cover the R22 and the R12 and just drop 134A into the system. You obviously got to replace the parts because it has different pressure values, just like most refrigerants do. Okay, it says it's the alternative refrigerant of choice for CFC 12 and HCFC 22 in many medium and high temperature stationary refrigerants and air conditioner applications, and 134A as a replacement, I believe, for R12 in the cars, for the refrigerant in the cars. The reason for this is that the pressure-temperature relationship and the latent heat values of the HFC 134A are very similar to those of R12. The automotive industry is using R134A in place of R12 because of its low host permeability along with satisfactory efficiencies. R134A suffers capacity losses when used as a low temperature refrigerant. Polarity differences between the commonly used organic material oils and HCFC refrigerants make HFC HFC 134A insoluble, thus incompatible with mineral oils used in many refrigerants and air conditioner applications today. HFC 134A is not a drop-in refrigerant replacement. So let's see, taking all of that again, it seems to be that it says it suffers a capacity loss when used as a low temperature refrigerant. I guess that's saying like in chillers. Okay, and the polarity difference between commonly used organic mineral oils and HFC refrigerants make HFC 134A insoluble, thus incompatible with mineral oils used in many refrigerants and air conditioning applications today. Okay, R134A system must employ synthetic synthetic polyester or POE, and polyalkyl glycol PAG lubricants. So HFC or R134A must use synthetic polyester POE or polyalkyl glycol PAG lubricants. 134A is also replacing R12 and CFC 500 in many centrifugal and reciprocating chiller applications. So now it's starting to move into the chiller applications as well. Let's see. It's also being looked to replace R11 as well. Ester-based lubricant are also acquired in these applications because HFC 134A's incompatibility with organic mineral oils. So you need the ester-based lubricant for the R134A for the chiller applications. It's an improvement, but it still has some reduction in capacity. Okay, now let's look at the blends. Okay, blends. In the meantime, widespread research is being done for a drop-in replacement for CFC 11 or R11, R12, R502, and R22. And many other refrigerants. They call near azeotropic refrigerant mixtures, or NERMs as abbreviation, NARM, are now being researched. So that's near azeotropic refrigerant mixtures, NERMs, are now being researched and manufactured by major chemical companies. NERMs, or blends of refrigerants, are being mathematically modeled with computers to tailor refrigerant blends characteristics to give maximum system efficiency and performance. Even vapor pressure can be adjusted by varying a percentage of each constituent in the blend. In fact, many refrigerant manufacturers will use the same blend but vary the constituent percentage in the blend for use in different evaporation temperature applications. Okay, percentage composition changes are also used to lower composition ratios and discharge temperatures for maximum operation performance and efficiencies. Refrigerant blends can be HCFC based, binary blends consist of two refrigerants mixed together, but ternary blends consist of three refrigerants. Only interim CFC replacement because of their chlorine content, but HCFCs constitutes a major percentage of some blends. The blends have lower ozone depletion and global warming potential than most CFCs and HCFC refrigerants that they are replacing. The HFC-based blends will be long-term replacements for certain CFCs and HCFCs until researchers can find pure compounds to replace them. Okay, now they talk about the R22 replacement. R22 can totally phased out by the year 2030 under the Montreal Protocol, with partial phase out starting sooner, which I believe was 2020, right? Okay, R410A is a near as a and I believe most of the ones that's in the 400s, like 410A and 500, are blends. But use that rule of 90 to calculate if so. But R410A is a near azeotropic refrigerant blend of R32 and R125 of R32 and R25. R410A is a blend of R32 and R125. R25 was what? A R25 is a HFC. HFCs, hydrofluorocarbon, HFC. This binary blend has very small temperature glide and is negligible fractionation potential. Because R410A is a near azeotropic, it has a liquid charge. I mean, it has to be liquid charge. So 410A has to be liquid charge. Its safety classification is A1/A1. Okay, so 410A has a higher efficiency than R22. 410A is a HFC-based refrigerant blend, which is being used by original equipment manufacturers on new equipment in place of HFCs. I mean HCFC 22 or R22. It is a long-term replacement for R22 in commercial and residential air conditioning applications. 410A system operates at a much higher pressure, approximately 60% higher than the standard R22 systems. In fact, R22 service equipment, hoses, manifold gauge set, and recovery equipment cannot be used on R410A system because of the higher operating pressure. Service equipment used for 410A must be rated to handle higher operation pressures. Safety glasses, gloves should always be worn when working with 410A. 410A systems use synthetic polyester or POE lubricants in their crankcase and have a high efficiency than the standard R22 system. So it's been working as the long-term replacement for the R22 systems, which is used in many home home air conditioner AC systems. Okay, I'm gonna have to come back for another audio study guide here.